In our last section of this unit, what we're going to do is use the triangle inequality theorem to identify possible triangles and then also talk about the side lengths and how they relate to one another. So let's go ahead with our one and only card that we have, which is for the triangle inequality theorem. So the main idea behind this theorem is that anytime you take two of the sides of a triangle and you add them together, it has to be greater than the third side. And so I kind of color coded it over here. So if I take PR and I add it to PQ, it has to be greater than RQ. If I take PR and add it to RQ, it has to be greater than PQ. And then if I take RQ and add it to PQ, it has to be greater than PR. So it's the only way that it will work and actually make a triangle. Now notice how it doesn't say greater than or equal to. So equal to will not result in a triangle. It has to be larger. Even if it's by just the smallest amount, it has to be larger. So here's some examples. We have some numbers, and we want to know if it's possible to form a triangle with the given side lengths. So, well, what do? Well, if we know the triangle inequality theorem means you take two sides, add them together, and see if it's greater than your third, then that's all we're going to do. So the first thing you need to do is 4 plus 9 and see if that is greater than 15, and we get 13 greater than 15. No, it is not. So I'm going to go ahead and put a little slash through that. It is not greater than 15. And so what that means is this will not make a triangle. And it's all because 13 is not greater than 15. All right, our second example here, we have 9.9, 1.1, and 8.2. So let's start with 9.9 plus 1.1, and is that greater than 8.2? So this becomes 11. Is that greater than 8.2? Yes. So then we move on down the line and do another combination of numbers. So 1.1 plus 8.2, and is that greater than 9.9? Add them together, we get 9.3 greater than 9.9, and no, it is not. So because of that, this will not make a triangle. So those three numbers will not make a triangle because of this right here. Okay, a couple more examples, 2, 2, and 2. So we have 2, 2, and 2, so take your 2 plus 2, and is that greater than 2? And we get 4 is greater than 2, which works. And of course, if we keep working our way through, you're going to keep adding 2, and you'll always get a greater than 2. So yes, because adding any two sides so any two side lengths gives a number, number greater than the third side. There you go. So that would be your reason. All right, and then our example in number 4, 3, 2, and 5. So if we add 3 to 2, is that greater than 5? So we get 5 is greater than 5, which is not true. 5 is not greater than 5. It's equal. And so because of that, we will not be able to make a triangle. So we'll not make a triangle. So if I were to, let's say, work with this a little more, or maybe one of these examples, let's look at number 2. If I were to come back and I changed these numbers and altered them just ever so slightly, and instead of this being 8.2, let's say I make it 8.9. Okay, so let's do a fifth example really quickly here. Let's see. I'm going to add example number 5. So, and I'm going to make it instead of 9.1, so, or sorry, 9.9 with 1.1, and let's say I make this 8.9 instead. So let's go ahead and do the problem now. So 9.9 plus 1.1, is that greater than 8.9? And we get 11 is greater than 8.9, which yes it is. Okay, so we're good. So now when I go to the other two, 1.1 plus 8.9, is that greater than 9.9? Well, we actually end up getting exactly 10, which is greater than 9.9. So that also works. And so then our third combination of sides would be 9.9 plus 8.9. And is that greater than 1.1? Well, of course it is, because one of them all by itself is already bigger than 1.1. But, it ends up getting you 18.8, which is greater. So these numbers will make, so yes, they will make a triangle. So again, it's because every time that we added two sides together, it was greater than the third side left over. Okay? All right, and then we just have these three examples, and then I believe I'm wrapping it up. Yep, we're all done after that. Okay, so in this one, what we've got is three numbers only two numbers, and the question is to find the range for the measure of the third side of a triangle. So what is the possibility of your third side? What's the biggest number it could be, and what's the smallest number it could be? So what we're going to do every single time is you're going to add them together, and then you're going to subtract them. So if we add them together, we get 12. When we subtract them, and I'm going to put little colons here, we're going to get 4. So that means our third side must be between 4 and 12. Now, your small number always goes here. It's always less than your variable in the middle, always less than here, and then large number. Okay, so it's always going to work this way when you write your inequality. So your second example, so we're going to add the two numbers first, which is 16, subtract them, and remember to always do the positive number because we're talking about length, so we have to have a positive number. So 11 minus 5 to get 6. So we do small number, less than, x, less than, big number. So it means it has to be between 6 and 16. Now it can't equal 6 and it cannot equal 16, but it can be really close to both of those numbers. So this would be your answer for number 2. And then your last example, there's your answer for number 1. And then for your last example here, so add them together and then subtract them. So adding them, you get 5.3. And then subtracting them, you would get 1.1. So that would mean that your third side has to be between 1.1 and 5.3. Easy peasy. All right, so there you go.